Hello and welcome to Energy News Live Q&A. My today's guest spent decades in upstream oil and gas, then went to what he calls primordial hydrogen. The idea that Earth's interior has been quietly making hydrogen for billions of years and leaking it out through chimneys while we argue about electrolyzer subsidies. Meanwhile, regulators are scrambling to decide whether this stuff is a mineral or a fuel or a bureaucratic panic attack. Please welcome the man trying to keep this whole thing tethered to reality, Vitaly Vidavskiy. Vitaly, welcome.
Thank you very much, Ernest. Thanks for having me.
For all of you watching us today, please use DMs, comments, emails, send your questions. We're here for you today. And for the start, Vitaly, can you give us a short introduction to your work, Avalio, and we'll continue with the market.
Yeah, thank you very much. Well, first of all, a couple of disclaimers. Disclaimer number one, in our assessments and evaluations analysis, we operate open data only from open sources. So a lot of companies these days operate in the stealth mode, and therefore we cannot comment. And please don't. We will appreciate your understanding if some of our comments are not up to date. Once again, this is because we operate the data from the open sources. Number two, this event, this chat is not an investment advice. So please don't use it for any investment decisions. So this is for your information only. So a bit about myself. I was born and raised in Moscow, Soviet Union back then Russia. I have a background in geology, geochemistry, master degree from the Moscow State University. I'm currently based in Perth, Western Australia, and with my family. So I'm the director of Avalio Pty Ltd, the startup company, privately owned company, exclusively specialized in natural hydrogen. So I first learned about natural hydrogen in 1985, long before lots of you boys and girls were born, when my current business associate, Nikolai Larin, back then my classmate, my personal friend, invited me to the seminar facilitated by his father, Dr. Vladimir Larin, at the then Soviet Academy of Science, about natural hydrogen. So in year 2005, we established the first ever commercial entity, private company, specialized in commercialization of natural hydrogen. Well, back then it was quite early, as you may imagine. We were alone in this field for pretty much a decade and a half until the group of researchers from France traveled to Russia to get introduced to the subject of natural hydrogen on the continents by Dr. Vladimir Larin and his son, Nikolai Larin. And later, they published a book about this very phenomenon. And this is how the whole story with natural hydrogen started for the rest of the world. So I just need to mention that natural hydrogen phenomenon was denied by official academia for decades and decades. And all of a sudden, the world woke up to this reality and recognized that natural hydrogen does exist. And so what we have now is, to the most part, is the result of Nikolai Larin and his father's efforts. So I'm just helping Nikolai Larin with this commercialization part.
Thank you. Fast forward to today, and where is this market today? We already spoke a few times from the beginning, and I think that what's really interesting for our audience is what is happening today in this market. What are the biggest issues and potentially breakthroughs?
Well, the first breakthrough was made by Nikolai Larin and his team 6 years ago when they drilled the first natural hydrogen well in the world, designated well, which was designed to be drilled for natural hydrogen, not for anything else. In Nebraska, the well named Horty NE3, so-called Geneva project, quite famous these days. The well wasn't even an exploration well, so because there was virtually no exploration before it, before spotting it, mostly due to the budget constraints. So the well have proven the concept. So it was drilled greenfield with absolutely no offset wells, as they called in oil and gas, no historical wells in thereabouts. And the well stroke hydrogen up to 44%, and helium up to 12.8%, which was measured 4 years later by the independent lab. So today the industry is developing at quite fast pace. There are about 100, maybe 110 startups around the world. Most of them are privately owned. So once again, this is why we don't really know what's going on with most of them. But it's safe to assume that the vast majority of these startups, these companies, are into the R&D or early exploration. Very few of them are drilling. To the date, there are about 35, maybe 40 wells drilled around the world, mostly in the United States, which is understandable because this is where most of the venture capital is. And none of these wells so far, once again, from the open sources, none of these wells was drilled with commercial result, which means all of the wells that were drilled, some of them stroke hydrogen, high concentrations of hydrogen, others seemingly not, at least once again from the published documents. But there is no positive flow from the well, no physical flow, and especially no commercial flow, which these days is going to be the next breakthrough. This is what the industry is waiting for. Everything else is pretty much, R&D. We've been in R&D for 3 decades. It took us about 30 years to build the model. Then 20 years ago, we started commercializing it. So totally we're working on the subject for about 50 years. It takes a while. It takes some out of the box thinking, because natural hydrogen is completely different substance, different from natural gas, different from helium, different from petroleum, and this is why natural hydrogen requires a very specific approach.
So we now have a 95% natural hydrogen accumulation in about 1.6 billion years old rocks. Is this a new exploration target type or still just a scientific curiosity until flows are at scale?
Well, it's somewhere in between. The problem is that with the scientific part, so if we speak about the process development, it's still sitting pretty much in the R&D, in the applied science domain. The problem is that the official mainstream academia, mainstream research groups, they haven't. They were not keen to look at natural hydrogen for decades and decades. And once they started researching this subject 5, maybe 10 years ago, they apply a very traditional approach. So everything they do, since the science these days is very much clinging to the grants and financial aid from different entities. It's very hard to imagine the formal researchers, career scientists, to challenge the mainstream model which is basically feeding them for some of them for several generations. So this in turn causes the research problem. That the results of R&D, the results of lab research, fundamental research, quite often are matched, forced to match the formal, the official, the broadly recognized concept, and this really hinders the progress in this new field, like some other fields, some other domains in science are hindered by the similar approach. So our concept, the concept we operate, it does challenge the mainstream model. And the funniest thing is that we are more successful in our, and we can prove it, we are more successful in our field results, where we can match the official scientists, mainstream scientists, in terms of funding. We are much more successful than the mainstream academia. And I don't really want to vent into this subject because it'll take us hours, but our results are much better. And once again, the only well we drilled as a group have proven the concept, and we are as successful or more successful than others because we have the model, the concept which predicts, which possesses the predictive force. We can prognose natural hydrogen flows, natural hydrogen resources, while others are trying to explain what they see in the field or in the scientific literature, in the papers. So this is the biggest difference for us.
I'm already looking forward to the Wednesday, and for everybody watching this right now, on Wednesday we have Vitaly Arnaut and Doug Wicks all together live here, and they will discuss very deep topics. Let's go back to next question. With over 110 companies now in natural hydrogen, are we in a rational exploration or pre-commercial crypto with drill rigs?
The period of hype about a couple of years ago, which finished about a year ago, and like almost anything goes through this period. Anything new. If you remember .coms at the turn of the century, or cloud technologies back in 2010, 2008, 2010. So the hype is over. This is a good thing and not so good, not such a good thing. This is a good thing because hype creates a lot of background noise, and it's very difficult for small companies like our company, like Avalio, to get through this noise, and for the potential investors to hear from us, from other small companies through this noise. So it's good that the hype is over, seemingly over. It's not so good because the investors' interest is cooling down. And in the absence of real results, which, as I mentioned, which a commercial flow would represent very well, the investors are losing their interest, and therefore the industry is going more and more under-subsidized, underfunded. Once again, it hinders its development. It doesn't seem to represent a problem for some of our peers, for whatever reason. People around us seem to be quite calm about this loss of interest from the investors. If I was in their seat, I would really shift the gears and start looking for alternatives, because drilling, exploring for natural hydrogen deposits is not something that's going to bring them success. unfortunately. But they keep doing it, maybe because they don't know anything better than this. And while they keep doing it, the investors are losing their interest and departing in truckloads. So it's a matter of time. Someone might strike a very good flow with positive flow rates. Others could try to change paradigm. Once again, we remain open to any suggestions for collaboration. But overall, if the investors depart from our industry before it becomes a major, then it's basically going to be over, unfortunately.
Yeah. So, yeah, everybody has kind of a line with patience. So, you argue for deep primordial hydrogen, and what single, say, 2425 data set most strongly supports or challenges your model?
Well, first of all, we started. Vladimir Larin, Nikolai's father, started working on this subject 57 years ago. Same year when I was born, and Nikolai was born, 1968. And it took him a couple of decades to realize that his model is a explaining most of the paradoxes and dilemmas accumulated by the official geoscience to the date, and it keeps happening, including other disciplines like astrophysics, for example, metallurgy, molecular physics, etc., etc. Nuclear physics as well, neutrino, geoneutrino, and so forth. So the biggest confirmation, the best confirmation that the concept works is that we keep forecasting, we keep predicting things. I mean, as a group, mostly the Larins, of course. We keep predicting things, and like in astrophysics, there are several new telescopes up on the orbit. The astrophysicists keep retiring old telescopes, and they're launching new ones. And these new telescopes keep discovering things that cannot be explained by conventional science, by the commonly accepted model. However, if we apply the Laren's concept, which works for astrophysics as well, believe me or not, because it's very comprehensive, the things, once again, are explained perfectly. And some predictions made by Vladimir Larin several decades ago, when we didn't have those fancy telescopes on the orbit, they come true. The astrophysicists keep receiving the images resembling, 99% resembling Dr. Laren's illustrations to his books and papers, believe me or not. So timing-wise, the things keep being confirmed by the astrophysicists as well. So if we come down closer to the ground level, once again, 20 years ago, natural hydrogen was unheard of. Okay, people been laughing straight in our faces. What are you talking about? These days, there was a hype, and more general public become aware of it. Alternative models, which are currently mainstream, such as serpentinization, pyrolysis, radiolysis, etc., which we unite under the nickname of geochemical processes in the crust generating hydrogen. We don't deny them. They do exist, but the problem with them is that they could be multimodal, which means these processes could go different ways, and provided that there are a number of different factors, agents down below, and things never get steady. Things always change. The processes those geochemical processes can go differently. For example, serpentinization, in simple terms, serpentinization process can be described by a couple of dozen formula. So, the formula chosen by our mainstream academia is just one of the processes, because Mother Nature is much more complicated, believe me or not. So the biggest problem with serpentinization and other zations, those geochemical processes in the crust, is that they seem to be unable to produce commercial volumes of hydrogen. There are several papers, for example, Jessica Murray et al. 2020 about rain graben, and Alexis Templeton et al. 2024 about ophiolites. A number of other scientists, researchers, they admit that serpentinization alone or similar processes alone cannot provide steady flow of hydrogen for millions of years. The standard cell of rock would be exhausted very soon, rather sooner than it would live through today, so we could see it producing hydrogen. But hydrogen keeps degassing, so it keeps coming from somewhere for millions and millions of years. And once again, we operate several formulas describing serpentinization, requiring hydrogen as a prerequisite, not as a product in the right side of the equation. No, on the left side of the equation as a prerequisite. And this process has the right to exist same way in Mother Nature as it does on our job board. So the problem with the modern academia is that they choose something that fits into their narrative, and keep pressing, keep elbowing everything else. So, and this is how the real science dies. It turns into something else, unfortunately. So, since the science is official science, mainstream academia is not on our side, it doesn't make things easier at all, because most of the newcomers, most of the startups, they look at the formal academia and ask them for solutions. And the modern academia start operating the terms like knowledge gap or academical uncertainty or others, which I stopped collecting a long time ago, because they cannot provide with the answers because they don't have them. So open, out of the box, open-minded approach is, and multidisciplinary approach is the key. And this is where we professed, where we excelled, and this is why we are successful with our field results. All right.
I feel that this is getting closer, to actually being examined and listened to by the market. But what's really puzzling for me is, how did Vladimir back then knew everything without even having so many instruments, like all the readings, maps, and whatever else you have today? How, what, like, that is a real puzzle. Can you explain that?
Well, he was a geologist, and he was a bright, very capable geologist, geoscientist. Back then in 1960s, geology was extremely practical in the Soviet Union. He was a practicing geologist. So he worked a lot in the field, mostly in Kazakhstan. And he started seeing things which could not be explained by the model that academia operated back then. So he started looking for the answers, and he found out that there are none. There are no answers to these discrepancies. And when he approached the academicists, the reputable peers they basically advise him to stop looking this way and just look another way. Okay. I hear the same advice. Once again, it happens in different domains, different disciplines. Like in Egypt, for example, those frescoes inside the tombs. Some of those frescoes are very, very interesting and intriguing, and they cannot be explained by the conventional history science. And once the lady who gave us the guide around those tombs, we asked her, so what's the explanation? She said, well, I went to Cairo and I saw some academics and they advised me to stop asking. so I mean, this is what happens when the formal academic cannot find the answers. They simply stop looking, and they simply advise the person who asks to do the same. So he started thinking of it. Then he traveled to the Baikal area in East Siberia. And this is where the things started getting really interesting, because the Baikal area is the active rifting zone, continental rifting zone, where the Earth crust splits apart, and at quite significant rate, like centimeters per year. And he started revising the geochemical data for the Earth. He found a lot of discrepancies there, and then he started. He took on the very, very tedious task of comparing chemical composition of the Earth and Moon, Earth and the Sun, and the Earth and asteroid belt, meteorites, which arrive to Mother Earth from time to time, chondrites and other types of meteorites. And he built 3 very famous charts, which are very famous these days. And the charts demonstrated that basically he arrived to the conclusion that the mechanism of material distribution after the proto-sun exploded, the nebula, the new star exploded, it was different. It wasn't solar wind as described by the mainstream, and still described, believe me or not. It was something else. And this something else was the most revolutionary thing in the science for the past 100 years, maybe more. So he discovered that the chemical elements were distributed across the solar system based on first ionization potential, which is the energy required to tear the outmost electron from the atom, okay, to make an ion from the atom, any chemical element, and this energy was governing the energy required for each particular chemical element was governing their distribution across the solar system, because the nebula created the magnetic field, and magnetic field around it became a filter, a screen, keeping some elements closer to the sun or within the sun, and others letting them go as far as they could based on their first ionization potentials. Sorry for diving deep into this kind of stuff, but it's naturally necessary.
It absolutely is worthwhile.
I hope so. So this stuff, the problem, Vladimir Lenin's problem was that very few people on the planet Earth were able to participate in this discussion at all. Anywhere, really, not just back in the Soviet Union, but around the globe. And still, this is a very challenging subject for most of the academia. I'm not an academicist, I'm not. I'm a very practical person. I just have to operate these things, have to be able to explain them to the general public, which I'm doing right now. Unfortunately, this is too much for an average investor, and I can blame them because they are specialized in a completely different field. So when the investors listen to us, they turn to their consultants, and consultants, predictably enough, work for mainstream academia. And guess what the consultant's opinion is? So this is our biggest challenge with investors for the past 2 decades. And this is why we are struggling with commercialization, because the concept is too challenging. Yes, it brings us practical results, very good results, but the scientific part, sooner or later we start discussing it. We try to avoid it as much as possible, but we have to at some point, and this is why. So other researchers, other models cling to more simplistic things that could be modeled and modeled in the lab, in the autoclaves, in the lab environment. And yes, those serpentinization reactions do exist. Once again, the problem is that Mother Nature is not a sterile lab. Mother Nature is not a lab assistant walking around in the sterile white coat, mixing stoichiometric, precisely measured amounts, weights of reagents, of prerequisites, and mixing them in a very controlled atmosphere. No, sir. Mother Nature is much more complicated than that. So these processes stimulated in the lab, they explain pockets of activity in the crust, but not the whole thing.
Back to today. South
Yep.
Australia moved fast on natural hydrogen, the rules and laws, while others still argue mineral versus petroleum. Where are regulators getting it all wrong?
Well, to me, it needs to be regulated. It doesn't really matter whether the regulators decide natural hydrogen to be a mineral or gas. Most of the countries around the world, they put natural hydrogen under the petroleum roof. Because petroleum legislation exists in the majority of countries, and it's the hydrogen is a gas produced from the depth, from the ground, and it's quite easy to amend the existing petroleum acts or petroleum legislation with a simple box which needs to be checked for natural hydrogen, but bureaucratic procedures sometimes tend to get quite lengthy, quite long, and this is why some of the countries or some of the states in Australia, for example, haven't figured it out yet. So there are other bits and pieces related to the bureaucratic procedures, like applying and obtaining the exploration permits, licenses, etc., etc. This totally depends on the level of regulation in each particular country or state. Some in the United States, the United States are blessed with legislation entitling the landowners to own everything beneath their parcels of land, down to the earth core. So you basically strike the deal with a landowner, with a farmer, or maybe it could be federal land, and it's all yours. So they are very fortunate in the States. In other countries, the process needs to go through numerous stages. In some of the countries, the environmental part is extremely cumbersome, very, very lengthy and difficult, especially for small startups like us. So once again, every country is different, and it's just up to them whether they are going to be there on time or going to be falling late behind the rest of the humanity in this natural hydrogen race.
So we will switch the topics here and there due to the questions coming in. So can you comment at all on Alavio's current work with QIMC? This,
QMC. Okay.
yeah.
Yeah.
So how their exploration model relates to your methods relating to the hydritic earth concept and what we can expect from this drilling program?
Well, we kind of bumped into each other online with John Karagiannis, and the QMC CEO and president. So John is currently a very good friend friend of mine, John attracted our attention by repeatedly stipulating that the company QMC are not looking for the accumulations for the deposits of natural hydrogen. They rather look for streams. They pursue the dynamic model, which is what we are after. And since we seem to be the only two companies in the world, maybe there are others which I'm not aware of, but we couldn't go past each other. We couldn't miss each other. So we have the agreement of sorts. We are helping each other in our research. We consult them; they help us. So so far there is. It's too early to disclose anything concrete about it, especially that QMC are publicly traded company, so I don't want to hurt things in any possible way for them, even undeliberately. So I believe we are, or I myself and Nikolai, we are of the opinion that QMC are the closest to the success because they are looking for the right thing. We have our position on the natural hydrogen origin are slightly different, but the model, the most practical part, the most important part, is basically the same. So therefore, they utilize very similar exploration methods, like us. Once again, slightly different, but they are on the right track, and especially that their project in Nova Scotia, where they obtained extremely good results through the soil gas detection campaign. So once they announced about the results and their intention to drill, overnight, the areas around their permits was taken by one very prominent company, extremely well funded, and this company basically it was a confirmation of sorts that QMC are on the right track. So this is
what are your thoughts on Koloma's recent 7,000 plus claims staking or surrounding on QMC in Nova Scotia?
You named it. It's not directly Koloma. They use a different entity under a different name. I don't remember it. If my memory serves, established last October, a couple of months ago, a fresh one. Once again, if we operate our concept, which is once again so far it is successful and not rebuted, it doesn't really. According to our concept, it doesn't really make sense to peg the land around the prospect, because this is not natural gas. This is not minerals deposit, uranium or gold. The nature of the morphology of natural hydrogen anomalies on the surface, they're very limited. They are very constrained to a small area, and this area is already taken by QMC. So pegging around it is just, it's some land. There might be some results in terms of soil gas detection. I'm not sure if this other company is practicing soil gas detection because they operate in stealth mode. So they could even find something because after we published our paper in 2022, all of a sudden the industry started being interested in deep vertical, subvertical faults. Okay, just a coincidence, of course. So those faults, they stretch quite far. But problem is that natural hydrogen is actively degassing through some certain sections of these faults, and the task is just to find them, and later to drill into these actively degassing sections, which is a challenge on its own. I spent quarter century in oil and gas in drilling and well servicing, and I know how difficult is to drill into the active faults. There is a bunch of technical challenges associated with it, but it's a different story. So, cut long story short, good luck with that. Land grabbing, unless they are extremely lucky, land grabbing is not the strategy which I could recommend to the acute researchers and explorers in this case.
So, talking about that, we are ending on the flows, if I'm getting this right. And what we need to do is to catch the flow. We cannot have the reservoir because it's not existent, correct?
Yep, exactly. Reservoirs, first of all, not that, pressurized reservoirs of natural hydrogen do not seem to exist because natural hydrogen is a very volatile chemical element, as we all know. It possesses the second smallest atom in the universe.
I like to say promiscuous.
Yeah, well, you may say so. Helium is the smallest atom, and hydrogen is the second smallest. But helium is chemically inert. It's called noble gas because it doesn't react with anything. It's basically, we can say, it's impotent. While natural hydrogen is extremely sexually active guy. It enters the reactions with anything, almost anything it can see within the vicinity. So with millions of years, it kind of chews through almost any cap rock, sealing those potential reservoirs. So they just become accumulations, which could possibly slow down hydrogen on its journey towards the surface along the lithostatic pressure gradient, but not forever, and not in the pressurized state, unfortunately. So the case of Mali is perfect in this sense to demonstrate this saying, because they have to shut in the well in 2 or 3 times a day to let it accumulate sufficient pressure to keep producing, because they produce from one of these accumulations in the sandstone beneath the dolerite, if my memory serves. But the story with it is not about accumulation itself. It's about the way it is replenished. It's replenished through one of those chimneys, whatever we call it, from down below, from very, as we believe, very deep source. And the depth of the source could be identified through the isotopic geochemistry, isotopic signatures, and this is what the well in Nebraska was tested to: extremely low minus values, which is high cutoff protein, which they call others call depleted with deuterium, but it's really about protein, not deuterium. So similar story in Mali and in other Kansas, for example, as well. And the main question is this accumulation is it replenished or not? Because if it's not replenished, then it's going to be depleted rather soon, and it's not coming back. So
Yeah.
whether we what else we do? We can frack it. We can try to put some chemicals. Stimulated hydrogen in this regard. There are a lot of questions which we prefer not to ask. We prefer to wait for some results. There are which are hopefully coming from Oman, from Alexis Templeton and her team in Oman. Hopefully soon.
So, what minimum duration and stability of flow would you require before calling anything a true discovery?
Um, well, the flow. These flows are stable for thousands of years. They shift, but rather slowly. In geological time, they could shift rather quickly due to, let's say, some tectonic impulses or other processes. But this quick is thousands of years. Regularly takes millions of years. By the way, this is the explanation why some of those so-called fiery circles, which we call circular depressions, why some of them are barren and others are active. Those barren guys, there was a flow millions of years ago, right there, but then it shifted. And the lake, the impression on the surface remained. It stays. We call it a geomorphological feature, okay, in geoscience, which is the landscape feature. So it remains, it stays, but it's barren. Others are very active. They emit hydrogen, and I bumped into very active lakes like this in Western Australia, where my gas detector started showing hundreds ppm before I drilled the borehole to run the probe in the ambient air, hundreds of ppm in the ambient air. Poor little thing couldn't bump test itself, couldn't start properly because the ambient air was saturated with hydrogen. So this is how some of those structures, how active some of those structures could be. But once again, so it is important to find this flow, to establish its existence and morphology and kinematics, fluid dynamics, hopefully, fingers crossed, with geophysical methods. But once again, we need to drill a well, maybe several wells, to identify its commerciality, okay, to establish whether it's commercial or not. And because those structures are not homogeneous within, they can possess quite different petrophysical properties within their bodies, their morphology, and therefore we can identify the productive parts, keep good ones in, bad ones out, and attempt to drill into those productive parts of those chimneys. But there is no guarantee, and this is what we've done in Nebraska. We drilled the well into one of those structures, but not into the best part of it. These days, we have much better ways to identify the best drillable targets. And we are prepared to do that.
You warned founders about predatory investors in natural hydrogen specifically. What are the biggest red flags a technical founder should run from immediately?
Well, predatory investors. The thing is that in our case, it's almost impossible because there are very few folks on the face of Mother Earth who really understands how the things work in terms of natural hydrogen. So, hostile takeover of Avalio wouldn't really do any good for those predator investors, because Avalio is just a mechanism, it's just a vehicle. for achieving something bigger. So and the brains don't go with the Avalio unless they split my skull or Nikolai's skull, so to say, hopefully figuratively speaking. It doesn't work like that. And this is a perfect. So natural hydrogen is probably the most perfect example today of how the things could work if the win-win scenario was adopted. All right, because we possess knowledge, we don't have funding, and vice versa. No offense, no offense. Okay, until otherwise is proven. And this is probably the biggest surprise, if not frustration, in my long career. This is the first time when we see black and white that long time R&D, research, exploration, and successful one, it doesn't really matter. It doesn't really matter what you know. What matters is whom you know. And in that, well, sorry guys, we are proficient in other things. so unless our peers get tired of continuous unsuccessful results, barren wells, dry holes, and come and see us. We remain open once again.
Let's walk through some of the latest examples for the end. Gold Hydrogen reports 97% natural hydrogen at Ramsey 3. What's the one missing data point you still need before calling it a truly commercial?
We have to see whether it flows or not. If there is an active flow, it could be rather weak, because natural hydrogen doesn't seem to be flowing with high pressures. Pressure differentiator, pressure drop is not significant, but there has to be a flow, like in Mali. So, cut long story short, in simple terms, the whole industry are currently exploring for the equivalence of the Mali well, Bugu 1 well in Buraki Bugu village, to the bigger scale, and multiple wells like that. Okay, so, and this is the ultimate goal, because the well in Mali was accidental find, and it's pretty simple. They've been drilling for water in 1987, never thought of natural hydrogen or anything else. But the well keeps producing. So this is once again the best confirmation, the best proof that it's a flow. It's not. It's a flux. It's not a deposit. So if there is a flow in South Australia, Yorke Peninsula, then bravo. They hit the gold pot. Gold hydrogen hit the gold pot. If not, well, keep looking until run out of funding. Once again, we offered our collaboration to Gold Hydrogen Management. They politely declined. Okay, they're on their own.
But that's amazing. Like, you have accidental find in Bugu, and it's just there to prove us that it's there, it exists, it can be done. Someone already done it, and we still need to scratch our heads and find ways to actually multiply this. It's amazing. But to the next question, QMC keeps mapping multi-kilometer corridors with high hydrogen in shallow soil and gas. When do great anomalies justify a full development plan?
Well, I don't know. It depends on a number of factors. I'm not 100% familiar with their practical results, because some of them are confidential. They have, once again, they are planning to drill several wells in Nova Scotia and possibly in Quebec. We will see from the results. Their chances, once again, when we deal with subsurface subsurface substances and resources like natural hydrogen, minerals, oil and gas. We deal with the probabilities, okay, chances. So QMC chances from our viewpoint are the highest in the industry so far because their model is, it seems to be correct. And the results, the early results confirming proving this model are extremely encouraging. So this is all I can say, and the drilling campaign will show. Fingers crossed, and we put our praise for them that they hit the flow. So if you want to start purchasing their shares, do it now. It might be too expensive a couple of months later.
We'll think about it. So, if you had to pick one jurisdiction today where geology, regulation, and capital are best aligned for the first truly commercial natural hydrogen project, where would you put your own money at and why?
The United States. The United States of America, because so many pieces fall in place there. There are the legislation. I already mentioned it. The legislation is probably the best, and especially for small startups like us, because it doesn't require applying for a permit, for license or lease, doesn't require enormous efforts like in other jurisdictions. So we simply don't possess such resource in other jurisdictions. So geology is extremely heterogeneous. The United States is a big country, and there are a lot of macro tectonic structures which, in our opinion, possess a lot of potential in terms of natural hydrogen productivity. Once again, before we start drilling multiple wells, is just an opinion. All right, and the market is there. A lot of explorers forget about the market, but think about this. If you discover natural hydrogen El Dorado in the middle of nowhere, what are you going to do with it? How are you going to use it out there where there is no industry, no off-takers, no consumers? Transportation is out of question. The losses will kill the whole story commercially. So this actually, as a matter of fact, this pushed us to change our commercial model from we will discover hydrogen anywhere to we will discover hydrogen, well, as close to your backyard as it's humanly possible. All right. So we call it hydrogen on demand, fancy name. And this is the recent addition to our commercial model. And we offer to explore, and with high chances of finding hydrogen, natural hydrogen, in the commercially proven, commercially viable vicinity to the off-takers operations, because natural hydrogen is blessed by it's very different from petroleum. It may be found almost anywhere. Big question mark is about its commercial volumes, of course. But overall, if we speak about the probability of discovering natural hydrogen in XY coordinates, the probability for that is much higher than that for oil or natural gas.
So, based on Ramsey, the Quebec Corridor, and other 24-25 work, is an FID level natural hydrogen project before 2030 realistic or still wishful thinking?
For gold hydrogen?
Anyone?
Or
Yeah.
overall? Anywhere. Okay. Well, because Ramsey is just one of the wells, 3 wells, new wells drilled globally, and thanks to gold hydrogen efforts, these were the first 3 wells drilled in Australia overall on the continent, but the majority of wells are drilled in the United States. The vast majority of them are drilled in the vicinity of mid-continent rifting system. mostly in Kansas, and so far with no significant results. The quick answer is I don't know, because I don't have a crystal ball, Arnes. There are so many factors. Well, under the even in the United States, under the current administration, renewables are not treated really favorably. On the other hand, drill baby drill this is what we need, right? Because we have to drill. So there are so many factors, political and financial and other factors. The price of petroleum, it's unpredictable. It could go up, it could go down, and the alternative energy projects economy depends on it. Believe me or not, the higher the price for petroleum or oil or natural gas, the more commercial viability for renewable energy, for alternative energy projects, and vice versa. So other way out. So I don't know. I wouldn't really target any 2030 or any fancy dates like that. It goes the way it goes, and it depends on the investors in investment community. There is a huge AI bubble on the market these days. Everyone is talking about it. It's not just my opinion. Once again, I operate open data from the open sources, which attracts lots of investments, and dries out other domains, including natural hydrogen. You can invest into AI and get filthy rich tomorrow. Why bother with natural hydrogen, which consists of probabilities? Probability here, probability there, chances are, and so forth. Academical uncertainties. so we should understand those poor folks sitting in the oak-lined boardrooms for VCs and investment funds. They don't choose between green hydrogen or natural hydrogen or different models of natural hydrogen formation and degassing. No, sir. They choose between alternative energy and AI or commodities, other commodities. In Australia, for example, real estate is the second biggest market, believe me or not, after mining. So this explains it pretty well, I believe.
Yeah, return on investment. So if 25 till 27 passes with no clear commercial breakthrough, what honest conversation should this industry have with itself and with the public about what natural hydrogen is and what it isn't for the end?
Well, in any domain of science, in any discipline, if one concept, it doesn't really matter whether it's mainstream or not, if a concept doesn't work, sooner or later the research starts flowing in another direction. The academia starts looking at the different concept, and just checking them one after another. So we are waiting for this to happen in natural hydrogen, because you mentioned HNAT in Paris the last month. The main conclusion which was made at that at that conference, they keep calling it summit for some reason, is that the stationary model, the deposits model, is likely to lose its steam. Okay, and GeoXpro Online published a short article about it. So thanks for that. So this is probably true. So I'm wondering what the next step is going to be. Okay, switching to the dynamic model, which, by the way, was recommended by Dr. Omar Maiga, who spent 10 years working in Mali in his paper published a couple of years ago. If you guys want to work with natural hydrogen, you have to adopt a dynamic model, partially or maybe wholly, maybe entirely. Forget about those deposit stuff. He published it 2 years ago. It's not just us, the crazy Avalio guys screaming out loud, "What are you doing, guys?" No, it is being said by other research. The preference of the industry is to pretend not to hear it. Okay, and those warnings, those calls might become margin calls for some of them if they don't start listening. So, and this is not some gravely crystal balling I'm doing here. This is how the things go in once again, in any industry. If you keep stubbornly insisting on the concept which seems to be failing in practical life, then your days are counted. Basically, your business as such, dollars and pennies business, is doomed. Sorry, no offense here. This is the laws of Mother Nature, of economy. Okay,
Yeah.
so my advice: start looking into the dynamic model, guys, before your investor calls you and says, "Wrap it up. I'm tired. I'm quitting." Okay, this is my advice.
Vitaly, thank you for being my guest today. And I'm
Absolutely.
truly looking forward to the Wednesday and seeing you again with Arnaud and Doug. So, for everybody watching, join us on Wednesday, same time. It will go deep.
Looking forward.
Thank you.
Thanks.